Alright, welcome back guys. We have a video for you today about using and converting electrical energy. I'm Ms. Agar.
Mr. Bremberger.
Here we go.
Big ideas. We kind of divided our information here into 3 parts, right? Okay, 4 parts. Big idea number 1, right? Both electricity and magnets can produce motion. Again, for those of you that don't recall from 7th grade, motion equals movement. The ability to move an object a distance is energy. That is called doing work. Okay, in order for you to, have energy in a situation, you must be doing work, and work requires some movement of an object. And finally, the last kind of big idea here for the first section is that energy cannot be created or destroyed. It simply changes its form. That would be the law of conservation of energy, which is a lot like the law of conservation of charge, which we studied in the last unit.
So there are lots of types of energy. We'll be looking at a lot of these types as we go throughout the activities of this unit. We have mechanical energy, which if you have a hard time thinking about what that is, you can just kind of think of it, it's always going to have to do with some sort of movement. Chemical energy, electromagnetic energy, should have a little idea about that after we've studied electromagnets. Nuclear energy, sound, potential energy, you may have heard this before in your younger years. Potential energy is going to be stored energy. And finally, electrical, and that is always our goal. If we want to be able to use the energy, we want it in the form of electricity.
Alright, here we have a variety of different ways for us to kind of access this energy. We have fossil fuels, we have solar energy, which can come through the sun's radiation, or electromagnetic waves. Remember that spectrum that we talked about back in our weather unit. Light travels in many different sizes, from visible light to ultraviolet and what's the last one? Infrared, sorry. So visible, infrared, and ultraviolet all have to do with the sun's radiation and those electromagnetic waves. We have chemical batteries that can give us chemical energy. We can bust apart an atom to give us nuclear energy. We can harness the movement of oceans and tides. We can even gather steam from the earth, or the heat that's created below our feet. Also, many of us have heard and have seen wind generators. Those can also be used for electrical energy or as a resource. And finally, moving water or hydroelectric power.
Alright, so at the beginning we told you that energy is not created or destroyed. We just come up with different ways to convert energy. So we're going to look at 2 examples as we go through. First, looking at an electric motor. That is going to be one of our best examples of moving from electrical energy to mechanical energy. So the electrical energy is causing a movement to happen. Our other example in an electric generator is we take some sort of movement. It could be from hydroelectric water wheel, could be from a windmill, anything like that. Some sort of movement creating electricity for us. Remember that energy from electrical currents is just what we call electrical energy. And then energy an object has due to its movement or position is that mechanical energy.
All right, the electric motor, again, like Ms. Agar just said, this is going to utilize electricity and make something move. So in this case, the tool that is going to help us do that is an axle. Okay, so us hooking up an axle to those electrons, we can use the movement that exists with that turning device to get something to spin. Think about all the different types of things that may use a motor or may cause something to turn. Why don't you, take a sec, pause the video right now, and see how many ideas you can come up with. Me personally, one of the outstanding examples that I can think of is a ceiling fan, as something that utilizes a motor. Another thing that utilizes a motor would be like a car window. Those of you that don't have the old style of roll down the window. I know I get kind of ticked off and frustrated right now because the motor in my car window is broken, so it doesn't work as well. It really doesn't work at all, and so it can be kind of frustrating. Ultimately, though, those motors are taking the electricity and making something move.
All right, we are moving on to generating electric current. So this is the second section of the chapter. And looking back, we just looked at how electricity produces motion in the example of a motor. And I'm here to tell you that the opposite is also true. So not only can electricity produce motion, but motion can produce electricity.
Right, and the way that happens is by inducing electricity or utilizing induction. So by taking those electrons and getting them to move near each other, we can use, again, their dislike for one another to create some motion at the subatomic level or with those electrons and get them to kind of run around. So what are the two ways that a wire and a magnet can produce current? Well, number one, we can take that coil of wire and move it into a magnetic field. So taking that conductor, which has a whole bunch of free electrons, and getting it to move or spin within a giant magnet. That'll give us a generator. We can also do the opposite. We can take that magnet and run it into a coil of wire. That'll drive the electrons crazy in that wire and get those to move by induction as well.
And you will see an example of this second one here in our activity 3 of this week.
Again, notice both use movement. Okay, they both achieve that mechanical energy.
All right, talking about current kind of in general, an electric current will be produced in a conductor when the conductor moves across the lines of a magnetic field. So that's kind of exactly what Mr. B was just describing. The flow of that current can either be constant, just moving, if you think about the electric currents that we've seen in our circuits, just kind of flowing in one direction, or they can change direction.
And we have names for those different types of current traveling ways. First way that our electrical generators utilize is called alternating current, or AC power. Right? In an AC or alternating current situation, the current moves in both directions through your circuit. So if you remember back to the circuits that we created, we actually, in the cases of using generators, can get it to move, again, in both directions. And it does that rather quickly. A great example to actually be able to see this exists in your own homes, more than likely. For those of you that have some of those older style alarm clocks with the digital numbers, if you shake those up, you can actually see the flickering of the alternating current. So go home and give it a shot. Also, the other type of current that we have been exclusively using is direct current. Right? Coming out of those batteries, we can only get the charge to flow in one direction, which, if you think about it, makes those simple circuits or the series circuit, honestly, kind of crappy, right? Because of the one direction or the direct current that moves through it. So ultimately, we found that alternating currents are the most efficient ways of transporting energy long distances, and this is why we use it today.
All right, so we've been kind of starting to talk about this idea of generators, and remember, this is our example opposite of the motor example we talked to you about at the beginning. So in a generator, this is going to convert mechanical energy or some sort of motion, some sort of movement into electrical energy. Whereas the motor we talked about at the very beginning did the opposite.
Okay, one of the key elements for a generator is the turbine. All right, here we have a bunch of blades that are kind of placed into a cylindrical or a circular device. Okay, and when we move things across those blades, like steam or water or wind, we can get that wheel to spin or create some mechanical energy. And that's the mechanical energy that we're going to use to kind of input into our generator to get that electrical energy out. So again, reading through this, we've got a turbine with a circular device made of blades. Flowing water will move through it, and ultimately the goal is motion. We're getting that mechanical energy out so that we can generate some power.
All right, here we have a picture combining these ideas that Mr. B was talking about. So the turbine that he just described on the previous slide, you can see here. So in this case, we have steam entering our turbine to spin these blades around.
And then again, it's that motion that is connected to an axle that has a tremendous amount of wire attached to it. That wire inside of a big magnet, literally a magnet, think of the size of this room, will have all of this wire kind of rotating in it rather rapidly, which ultimately induces the electricity out of that wire for us to use.
So, Mr. B, as you were telling me about this before, this is taking all of those electrons inside of there and kind of driving them crazy, right? Making them want to leave in the form of electricity.
Absolutely, yeah. It's that movement, that electrical energy that we're so crazy about. It needs so much.
All right, third section is about using electric power. This is very short. We are going to have an activity in this unit about how much power do you use. This is going to be an activity 2. A few equations for you here. Just power is equal to voltage times the amount of current. Watts is equal to volts times amps. Some of these words should be very familiar to you. We've talked about voltage being measured in volts, current being measured in amps, and now you will notice power can be measured in watts. To think about how much energy you use, there is an activity in your packet, activity 2, that will have you look at some of the devices you use in your own home. And to figure out that energy, you're going to end up calculating the amount of power it takes to use these devices, and then think about how much time you spend on those devices to figure out the total amount of energy you're using. Energy is going to be measured in kilowatts per hour. So again, the amount of power and the amount of time that you are using it for, and that is in kilowatt hours.
Don't freak out about the math here, all right? We're going to take you step by step right through activity 2, so you can breathe easy. All right, we're going to talk next about batteries. All right, section 3-4 deals specifically with how we take chemical energy and convert it into electrical energy. So in order to do that, we need to, again, consider kind of the different parts of a battery. We've been using batteries a lot lately, and now's our opportunity to kind of dig in and see how they work. So a battery is a combination of 2 or more electrochemical cells. Now, an electrochemical cell is basically a fancy term for a battery. Converts chemical energy to electrical energy, and as chemical reactions occur, the electrodes become positively and negatively charged. We're going to build our own battery in, I believe it's activity 4 or 5, just using some simple materials. A couple different kinds of metal, some water, and an electrical measuring device. So we all have that to look forward to. And here is kind of your picture of the electrochemical cell. Notice we have kind of a home for this whole thing to take place. Within the major structure, we'll have two different kinds of metals, okay, with your two electrodes sticking out of the top of your metal. Those electrodes, actually, the whole thing is the electrode. The things sticking out are your terminals, or where you actually connect to. So, because we have two different kinds of metal, we'll have two different chemical reactions occurring between the electrodes and the electrolyte. Now, it's those chemical reactions and the difference between them that creates a difference in voltage, that causes those electrons to come racing out of one side of your battery around your circuit to the other. Again, here we're looking at direct current, because the electrodes are only going to move, or the electrons, I should say, are only going to move in one direction.
Alright, that comes to the end of our video. Please don't forget to write down a question for us. In this unit, you do not have to model the information out of the book, so you should be excited about that. And then we would like you to proceed with activity 2 when you're finished with the video and your video modeling. And if you don't finish that in class today, please do that as homework tonight.
See you later, everybody.